Okay, so here's the final section, rational equations, section 6.4. Basically everything is being leading up to this. To solve a rational equation, you're going to need to add and subtract. Okay, so we're going to have to solve it algebraically, which basically means you have to add, subtract, multiply, and divide. Okay, to do all this stuff, right? Then we're going to solve a word problem using a rational equation. So, solving a rational equation, basically here's what you're going to do. Now this might not make too much sense until we do an example, but you're going to factor the denominator first. Okay, let's check that off because we are pros at doing that. We're going to identify the non-permissible values. We should totally be fine with doing that by now. Here's something new. We're going to multiply both sides of the equation by the LCD. Okay, so let's keep that in mind. Then you're going to solve by isolating the variable on one side of the equation, as usual. We should be good with that. Checking your answer, we should be good. So here's the only new step. Okay. So you can take a look at this example. You should take a look at it. Read through the notes. Okay, look at those. Look at that solution. Okay, I'll do an example with you. Solve the equation. What are the non-permissible values? So step one, look back. Step one was what? Factor. So let's factor. We have 9 over y minus 3 minus 4 over y minus 6 equals 18 over y, and it's going to be 18, 6, and 3 minus minus. So right away, step 2. Identify LCD maybe? Identify the non-permissible values. Okay, let's do that first. So the LCD, which we can clearly identify, what do you think it is? We have y minus 3 here, y minus 6 here. Then we have y minus 6, y minus 3. So the LCD, what's common, and what's the lowest common denominator, will be this guy right here. Okay, and I was supposed to discover the non-permissible values. The non-permissible values are, of course, y cannot be 3 and 6. Okay, y cannot be 3 and 6. Okay, these are flipped around. So now we're going to multiply everything by the LCD. Every term. I'm going to show this explicitly. So this is a bit of a pain, but what this will do is it will get rid of the denominator. So basically, I believe this is step 4, or step 3. Multiply by the LCD. Okay, and what this does is it gets rid of the denominator. Okay, that's what this does. You'll see how. Okay, minus y minus 6. Once you do this a couple times, you will never have to write it out as I'm writing it out again, because you'll probably see how to skip this step. I'll leave that to you. Okay, it's something that you should be able to figure out on your own. And if you're saying, why don't you tell me? Well, I'll just say, just do a lot of these examples and you will figure this out. Okay, so watch that. Y minus 3 cancels. Y minus 6 cancels. See how you're getting rid of the denominator? Oops. Sorry about that. And here, everything cancels. So what you just did is you're left with 9 times... Oh, stop it. And let me just erase that. Let's see, you guys can see that? Perfect. Okay. What that did is it left us with 9 times y minus 6 minus 4 times y minus 3. And the order here Doesn't matter, it could be y minus 3 times 4 or 4 times y minus 3. I like to write the constants first, and this is all equal to 18. So you can see it went from being a really confusing question to a really simple question, actually, because all we're going to do here is we're going to distribute. So 9 times 6 is 54. Minus 4y plus 12 equals 18. And now what we have is we are going to collect like terms. So we have 5y, then we have negative 54 plus 12, and that comes out to be negative 42 equals 18. And what we're going to be left with is 5y equals 18 plus 42, which is 60. So y will equal 12. So now we'll check our answer. Maybe we'll do this in green. If we check what we're going to be left with, and this is kind of an annoying check, but we're left with 9 over 12 minus 3 minus 4 over 12 minus 6 equals 18 over 12 squared minus 9 times 12 plus 18. Let's see if this is equal to each other. Because what we get on the left hand side, we have 9 divided by 9 is 1. So what we have is 1 minus 4 over 6. Is that what that's going to come to be? So 2 over 3. And on the other side, we have 12 squared minus 9 times 12 plus 18. And we have 18 over 54. Okay. And 18 over 54 is 1 over 3. 1 minus 2 over 3 is 1 over 3. So 1 over 3 equals 1 over 3. So this is correct. Okay? There is our check. Pretty straightforward, right? It's going to go slowly. Sorry about this little spot. Apparently it's kind of got glitched out. This program is struggling. Now, the last way to finish this off here, before we do the word problem, is talking about an extraneous group. Basically what's going to happen sometimes is you're going to have two. You're going to have a squared term. So imagine if y here was squared, then you'd have two solutions. You check them both. One of them may not work. It might not fit into your non-permissible values right here. Or it may. Okay, so let's see what happens here. So it looks quite ugly. It looks quite convoluted. I'm going to try my best. Difficult to write in this program with how glitchy it can be. But let's hope for the best here. So, same steps. I'll write that down for you. Same steps. It's all in green. Okay, now let's let this thing behave. We have 3x over x plus 2 minus 5 over x minus 3 equals negative 25. We factor the denominator. We get x, and we get 3. Actually, this will be 5 and 1. And no, this will be 3 and 2. I'm sorry. 3 and 2. Where am I getting 5 and 1 from? Let's blame it on this program again. I like to blame everything on this program. Okay, I'm just kidding. We get 3 and 2 minus and plus. There we go. Very easy in terms of the LCD here is just as usual. X minus 3, x plus 2. Nothing crazy here. So what I mean when you can skip a step is that you know that these guys are going to cancel. Right? You know that they're going to cancel. Maybe I'll skip the step and you'll be able to figure it out. This is all going to cancel over here. Both of them. So if you know those terms are going to cancel, then all you have to really do is write the other term. Okay, I write x minus 3 here because the x plus 2 actually canceled on top and bottom. Look back in the other step to see the full solution. But that's what you're going to be able to jump to. You're going to be able to jump right to here. Which really, I think, is a lovely way of doing it. But you have to be confident, you have to have practiced. Okay, we collect like terms now. Notice how we have a squared term. And now we have, and so that will imply you're going to have two solutions because it's a quadratic. And now you're going to have 14x. Notice how my writing is getting better too. Gaining confidence here. And we get plus 15 equals 0. It's a quadratic equation. You can't factor out of 3. I mean, you could. You get left with a fraction, so that won't be good. We could factor this. Or we could plug into the quadratic formula. Let's just do that. Let's not think. We get 14 plus or minus the square root of b squared, which is negative 14 squared, minus 4 times 3 times 15, all over 2 times 3. So let's just compute that discriminant really quickly here. And we're going to have 14 squared, or sorry, negative 14 squared, 196, minus 4 times 3 times 15. Yeah, 16. Oh, look at that. Let's make sure my writing stays good. Stays good. Okay. And that would be 4. So it's 14 plus or minus 4 over 6. And I'm just going to skip right to both solutions. So you get 14 plus 4 divided by 6, which is 3. So x equals 3. Or x equals 10 over 6. Okay, which comes out to be 5 over 3. Now, what you're going to do before you check both of them, because that could be a long procedure, let's just take a look at our restrictions, or our non-permissible values, which is x cannot be, look at this, x cannot be 3, x cannot be negative 2. So you have just eliminated that, right from looking at your non-permissible values. So all we're checking is, we're just checking 5 over 3. If you want, you could convert this to 1.6 repeating, okay, which isn't ideal, and I'm going to leave it as 5 over 3. So we have 3 times 5 over 3 over 5 over 3 plus 2. With the decimal, you would have an approximate, and it would be very close. It would work out well. If you use the same decimal from both sides, you should get the exact same answer. But I will plug this into my calculator and see what we get. So here the 3's cancel. So really what we're left with is 5 divided by 5 over 3 plus 2 comes out to be 15 over 11. My calculator will convert fractions for me. So this will be 5 divided by 5 over 3 minus 3. So this will turn out to be plus 15 over 4 equals, now we have 5 over 3 squared minus 5 over 3 minus 6. Okay. And when you divide that by 25, you're going to get 225 over 44. Now, 15 over 11 plus 15 over 4 is also 225 over 44. I suppose you should only pursue this fraction path if you're really, really comfortable with your calculator fraction button. You can totally use this 1.66 and you're just going to get decimals. You're not going to have to worry about anything. I'm not worrying about common denominators here. My calculator is actually doing this for me. So if you don't want to worry about common denominators, you can just go ahead and use this decimal expansion. You're going to get the same thing. Okay, so far, I mean, nothing new, right? Nothing new at all. Hopefully this step is okay. Hopefully that's okay. Now let's move to a word problem. I'm going to take a look at the example that I actually did for you. It says 2 friends share a paper route. Sheena can deliver the papers in 40 minutes. Jeff can cover the same route in 50 minutes. How long to the nearest minute does the paper route take if they work together? So Sheena can deliver these papers in 40 minutes. Jeff can cover the same route in 50 minutes. Right there you have a rate. Okay, you don't know the distance, but as you can see in my solution, the time it takes together, let's call T. This is in minutes. Jeff does it in 40. Jeff does it in 50. Sheena does it in 40. Which means if you skipped right to here, right to this step right here, the fraction of work done, okay, Sheena will basically do, she'll finish, not 40%, that's not what I want to say, like fraction of work done in 1 minute will be 1/40, okay, which is a bigger number than 1/50. So Sheena's doing more work here, but Jeff, he's doing 1/50. In T minutes, that's where this T comes from. Okay, we have T over 40, T over 50, and together, I guess that's what I wanted to say, is T over T. That will be the combination of the two. Okay, so basically the addition of both of their times together, their fractional work done, will equal the total, which will be 1 in this case. So it's very simple actually to solve, difficult to set up right from the gun if you haven't seen a question like this before. Okay, I'm going to show you a similar question. Stella takes 4 hours to paint a room. It takes Jose 3 hours to paint the same area. How long will the paint job take if they work together? It's kind of a cool question that you can answer this using rational equations, because it takes, basically what we're going to have here is we're going to have T, let's do this in red. We have T over 4 for Sheena, and we're going to have T over 3 for Jose, and that's going to equal the total time. So that's the total time, and I'm just going to put in brackets, that's actually T over T, okay, which reduces to 1. This right here is Stella's, and this is Jose. So right now Jose is pulling most of the weight, whereas in the previous question Sheena was. Okay, so Jose is pulling most of the weight here, and Stella's and Stella is doing basically less work. But all you have to do is solve this. Solve for T. Very simple. The LCD is what in this case? 12. Right, that's the common denominator. Multiply everything by 12. I'll show my work here. Obviously. What's the point of doing this if I'm not showing my work? So there we get that. These cancel, that turns into a 3. These cancel, that turns into a 4. Oh, this should be a 12. And we have 3t plus 4t equals 12. So we have 7t equals 12. So we have t equals 12 over 7. And t equals 1.7, I think that is. 1.7 hours. Just like that. Okay? There is no restrictions in this question. No non-permissible. Okay? So, that's it. That is chapter 6. So, once you're comfortable with all this stuff, take a look at the practice problems. So perhaps the most difficult problem in here would be something like this, the extraneous roots. Okay, so try not to be intimidated by this block. Ask me if you have questions. I just showed all my work explicitly in this block, okay, which makes it look ugly. Okay, but as you can see here, this would have looked just as ugly but I omitted that little horrendous step of multiplying by the LCD. So, work on the practice problems, finish the assignment, and then you can move on to the exam.